Now to the topic of my talk. Carbon capture and storage is the dream of most people dealing with coal, because it could be the rescuing technology to keep coal running. But research on this topic was comparably meager up to now. I will show what it would mean if we go totally to renewable energies. How fast can we make it? And do we need an intermediate technology called carbon capture and storage? It is extremely depending on how we deal with correct prices. At present, we are extremely away from correct prices for fossil fuels. Would we take into account all the health problems we have because of the burning of fossil fuels and the air pollution in cities? Would we take into account the destruction of our cultural heritage because of air pollution? Would we take into account climate change damages already occurring in some of the low-lying countries or for the Inuit in Alaska, and put it on top of the price of a kilowatt hour of electric current from a coal-fired power plant? The situation would be totally different. We have had two steps to go into the direction of approaching the correct prices. One is our eco-tax in Germany, and I would like to ask the Germans here in this room, do you know how much is earned per year by the so-called eco-tax in Germany for the government, for the federal government? I see only shaking heads, and in the wrong direction. So you don't know. It is 17 billion euros per year. And the money is to more than 90% used for social insurance. So who is getting a salary, as we say it in Germany, as Angestellter? Please raise your hands. Many, there should be most of you, getting a salary which is not a government guy salary, but a salary of an employee according to the public rules. Most of you are. Your payment into retirement pension funds would already be 1.7% higher. Wouldn't we have the eco-tax? Because out of the 17 billion euros, 16.2 are pushed into this social pension funds. Most of you did not know, I realize now. So it was wise to go into this room and not to only listen to climate research or the results of climate research. Now go to the next step of internalizing external effects. It is the Europe or European Union-wide emission trading scheme, which was in its second national allocation plan from Germany and France and Great Britain, so meager that the commissioner in Brussels wrote blue letters, as we say in German, telling them this is well below what we expect and what you should do. change. And for Germany, this single letter from a commissioner from Brussels reaching the Ministry of the Environment in Bonn or Berlin led to 45 million tons of carbon dioxide less per year in Germany, because the revised second allocation plan for the period after 2012 had 45 million tons of CO2 less emissions and had at the same time the obligation to sell emission trading certificates, 10% of them, not to sell, to buy, a company had to buy, and €500 million was swept into the environmental ministry. For the first time since their existence, they really have money now. And what are they doing with this money? It has to do with our topic. They invest roughly a third into research for renewable energies. Another third is market introduction for renewable energies. And the last third, or a bit less than a third, is given to adaptation in developing nations. By this, our government went a step forward compared to the Bali recommendations for the Copenhagen Protocol. Because it was said in Bali, a lot of the money has to be taken to adapt to climate change in developing nations, because we are the culprits and they suffer more than we. That's why they need financial help in adaptation to climate change. And this should be derived, it was said in Bali, from the emission trading schemes. So this is a first step into the right direction. But now to my talk, basic facts. It is always needed again and again and again, because meteorologists or other disciplines, if not dealing with climate research, are sometimes influenced by newspapers. And newspapers are absolutely not the correct way to get the information on what we know in climate research and what we don't know, because the interest groups for such a big topic have taken most of the newspapers into their direction. One way it is exaggerated, in the other group, like Frankfurter Allgemeine Zeitung, for example, it is downplayed tremendously. So some papers are close to the coal lobby, some are very close to environmental groups, and that's why you never have a correct information on a daily basis if you go through maybe 25 of the newspapers. What you as scientists should do is read IPCC reports. This is the best you can have, because leading scientists, a few are among you, will have had an opportunity to bring in what they know. And I have worked 8 years for IPCC, and when I am asked, what is your main experience being in IPCC? I said, always, losing my blinders. Because when I went in, I had a rather good view, from my point of view, of climate change. Then I realized, talking to many other disciplines, that most of what I thought we would know is not known, has still question marks. That's why when we were the first, writing the first assessment report, we divided it into, in working group 1, we know. We calculate with confidence. Our best estimate is, and we don't know. And this had a very strong impact. For example, we could not write at the beginning that water vapor, the most important greenhouse gas, by far the most important greenhouse gas in our atmosphere, has a positive feedback. This was still not known at this time. And we could not write in 1990 that the observations, although we saw a global warming signal already, that the warming is due to us. This could not be said in 1990. In our first elaboration, we said we may well need more than a decade to make this decision. It was less than a decade. It was in 1995 when we argued for having detected the anthropogenic climate signal in the observations. And I'm proud, being from the same institute where the first scientist said it publicly. It was Klaus Hasselmann, the founding director of the Max-Planck-Institut, in a press conference in March 1995, jointly with the Minister for Research. The signal, we have detected the anthropogenic signal. Half a year later, it was already part of an IPCC report, and it gave the famous sentence which caused the Kyoto Protocol. It's very clear now. The sentence was the following: the balance of evidence suggests a discernible human influence on global climate. I was among those 12 scientists trying to formulate this sentence in an evening session in Asheville, North Carolina, USA. And when we had Ben Santer finding the first version of this sentence, Larry Gates, later my supervisor in the World Climate Research Program, told me, Hartmut, you will see this sentence causes political action. And he was right, because only after had we detected the anthropogenic signal, a small move of the politicians was the consequence, which is the Kyoto Protocol, which brought the trend reversal for the industrialized countries in greenhouse gas emissions, and the European Union has no problem in fulfilling the Kyoto Protocol. Because we are enlarged now, we have integrated 10 countries of the former East Bloc, and they can offer to us between -15 and -60% in CO2 emissions. Since Europeans are always under one umbrella in the so-called European bubble, they will fulfill the Kyoto Protocol. No doubt about it. But the Austrians, they have to buy emission rights from Lithuanians or Hungarians. Germany can offer some emission reductions because we need to have -21%, but we have already reached nearly -24 at present. And something will still happen until the end of 2012, when the counting for the Kyoto period ends. There has to be an average over the last 5 years, so from 2008 up to 2012. You have now read what I have written here. I hope so. But I would highlight the lower portion. Development of developing countries is real. why did we have this tremendous economic growth on global scale recently, until roughly a year ago? Because more than half of the world population experienced an economic growth of between 7 to 12%. More than half of the world population. And even African countries, which in our minds are always the laggards, had an economic growth in most of the countries of above 5% in the recent years. So the developing countries are really developing fast. And for this year, the Chinese claim, and they were normally very correct in saying such things in the recent decade, they claim that their economy will grow less this year, but still with 6%, despite the so-called world economic crisis. And they will catch up again. And that's why we have a situation for climate policy making, which is much worse than we saw it 10 years ago. Because the growth rate of CO2 emissions is up again to 3.3% per year. This was the number of 2008, roughly estimated. And it was only 1% growth rate in the 90s, because the collapse of the Soviet Union and the economic downturn in the so-called East Bloc had led to a decade of nearly no growth in emissions. But when they entered the European Union in parts, they grew with 5, 6, and 7% again, despite their fallback earlier. And then CO2 emissions went up to roughly 3 or 3.5%, which is close to what we had in the 60s, where the strongest global growth of CO2 emissions took place. So we are now in a situation which is much worse than in 2000, when we developed these famous stress emission scenarios of IPCC. What was called A2 at this time is a bit lower than reality. That's why IPCC will change the scenarios, will have for the next assessment report new scenarios, and recalculate what is necessary to reach, for example, a 2 degrees maximum warming goal, which is kind of outdated already if you listen to most politicians. And this is now the key challenge. Development is the need for more than half of the world population, and at the same time, we need climate policy making. So we need to dampen the anthropogenic climate change rate for sustainable development. Sustainable development is the key goal of all nations, accepted in Rio de Janeiro. Also accepted jointly with this goal of sustainable development was working with the so-called precautionary approach, which was forgotten by the United States of America until very recently, but which is still the guiding principle in policy making in the European Union. That's why the European Union got opinion leadership, at least. Not real leadership concerning climate change issues, but opinion leadership, because the United States of America was so weak over the last roughly a decade. So halving the emissions until 2050 at doubling the energy demand. This is the task. The energy demand, even if efficiency increases are higher than up to now, the energy demand will at least grow by a factor of 2 until 2050. But at this time, all the scenarios said we should at least have reduced the emissions by a factor of 2. So we need a factor of 4 in decarbonization. And that's where the carbon capture and storage comes in, because not well-ventilated brains cannot believe that you can do it with renewables. Ask 100 managers of big companies the following question: can renewable energies give the full energy supply in 2100? At least 95 would tell you no. Only very few working in solar technology, they would tell you a different story. Now I jump over all these radiative forcing calculations and just present to you what standard wisdom is concerning warming. Now following a scenario called A1B, which is a medium scenario. But don't attach to these scenarios probabilities, because we do not know what humankind will do. Are we following the scenario A2, which means burning all coal we can find and not caring about climate change at all, believing a few economists still saying it's better, it's cheaper to adapt than to mitigate climate change, which is now no longer the majority view, but there are still some. Would we go along this scenario, then one of the models, about 18 have calculated in coupled ocean atmosphere land models the consequence. One of the models here, the Hamburg model, says there will be a very strong warming on continents. The maximum warming is in the Arctic, and a few areas in the ocean are nearly not warming at all, because these are the areas with comparably deep mixing every year. It's not the ventilation areas with the deep convection, it is the storms in wintertime, the Aleutian low, the Icelandic low, and the ring of depressions around the Antarctic, where normally the 500 upper meters of the ocean are well mixed at the end of winter every year. Since 3 meters of seawater contain the same amount of energy as the entire atmosphere above being at the same temperature, you can imagine what it means if you dump the heat into the upper 500 meters of the ocean. That's why these areas are the key areas for the increase in sea level, because of the warming going very deep into the ocean. But they are at the same time the areas with nearly no warming at the surface at all. And you could now go into details of such a model, and you would find how deep it is going one winter, the next winter. And if you compare it to reality, you will find that the groups dealing since a long time with these models, like the group in Princeton, or the Hadley Center, or the Hamburg Institute, the Max-Planck-Institute for Meteorology, they are very close to reality concerning the statistics of the January mean temperature, of the mixed layer depths of the ocean. Even precipitation is comparably close to observation, although it is very difficult to calculate precipitation in such a model with 200 kilometers mesh size. all models, except for very few which have disappeared from the marketplace, show this image. When we started in the World Climate Research Program, so-called model intercomparison exercises, all the groups coming and presenting the output of their models were very keen to be among the best. But step by step, some of the models just disappeared. And the countries bringing their models into the dustbin arranged for cooperation with some countries having models closest to reality. That's why most of the models nowadays are no longer so differing as they have been. Models which could not, for example, show the Icelandic low just disappeared, because such a basic feature of the general circulation of the atmosphere, if they can show it at the right place with the right pressure in the center of the depressions, they should just give up. This diagram is for me the most important in the Working Group 1 report of 2007. I translated first into German. Wer schon hat, kriegt etwas dazu. Wer Mangel leidet, kriegt nochmal was genommen. This is the interpretation of this diagram. Who has gets in addition. Who suffers already from water scarcity will get less. And for the European Union, this is a very dangerous diagram, because the Mediterranean climates all over the world, and Europe has a large portion in the Mediterranean, the European Union, will get less water, not only in summer, but also during the rainy season in winter. Southern Italy, southern Spain. And this is a very dangerous diagram for the livelihood in these areas. And these huge fires we always experience in the recent years, they are only in the Mediterranean climates, be it in Western Australia, or in Southern Australia, in California, in Portugal, in Spain, in Southern Italy, in Greece, and recently in Turkey. So it shows the drying out of these areas, and there is always a group of humans with a match, not realizing that it is dangerous to use the match. And then these fires get out of control. There is one country which was able to reduce the incidence of strong fires, France, by a simple law-making. They said, burnt forests cannot be used as a construction site. And then the fires not disappeared completely, but were much less. While Portugal and Spain could not, up to now, persuade their parliaments to do the same. And also in California, you may have heard recently that one of the match owners from 2006 got death penalty 3 days ago, because 5 firefighters were killed in such a fire he has started. You see how different the views can be on this world. For politicians, this diagram can be translated into millions of people trying to reach Europe. And they are very much afraid of this. We have made our own area, the European Union, eine Festung, as we say in Germany. We built fences higher and higher and higher against the flood of people trying to reach us. And this will increase. With each % less of rain in a certain area, averaged over a decade, this will have consequences. If you don't change agriculture. I saw a project in northern Burkina Faso where a very simple means was used to go against the drying out of the country. It was building small rocky fences which during the next rainy season were just stopping erosion, keeping the soil in the system. The harvest was by 30 to 50% higher, and the water stayed in the country and went into the ground instead of just flowing into the next larger river. It was a very simple project, but it had rather good consequences for this area of Burkina Faso. It was paid by Canadians, Danish, and German development aid. Only for the trucks, but not for the work. The work was done by local people. Consequences of inaction. What would happen if we don't react? The warming rate would be higher by factors of 50 to 100 compared to fast global mean changes in Earth's history. This is, when you look at Earth's history and try to find, except for planetoids damaging the Earth. But if you look to standard climate change over the last few million years, you will only find comparably rapid changes at the end of ice ages or strong glaciation. And it needs 5 to 10,000 years to melt away the big ice sheets. And so the temperature change over 5 to 10,000 years is in maximum 4 to 5 degrees. And now we are talking about a few degrees squeezed into a century. That's why it is 50 to 100 compared to fast global mean changes in Earth's history. This is the main message of the climatologists to the public. And there is a lot of confusion in the heads of geologists. They always come with the following saying: during Earth's history, ice came and went away, came back. We now know it was driven by Earth's orbital parameter changes. Why are you worrying? Then look at Central Europe. Why is it possible that a first-class pupil, 6 to 7 years old, can learn by heart all trees or tree species existing in Central Europe? It's only 36 native tree species in Central Europe. Why? Because of this massive up and down during the ice ages. Most of the trees just did not follow. If you go to very similar climates in northern Japan or North Korea, you will find hundreds of native tree species, because during the ice ages, there was not this massive growing of ice sheets and shrinking. There was less temperature change than here in Europe. In 5,000 years, the conditions for forests started at Saint-Tropez, the northernmost high stands of forests existed at the Riviera coast during maximum glaciation. And 5,000 to 6,000 years later, central Sweden could already have some pines. And this shows how fast the forest should go adapting to climate change rates. And now we have a factor of 50 at least more if we don't act. Then you can imagine that most of the species would just not follow. The fish can do, because they are rather mobile, but not a standard tree species. We made an exercise for the German government, a small group of 9 scientists in charge of giving every 2 years a major report, and in between smaller reports on self-chosen topics of global change to the government. And we made an exercise in 2003 where we tried to find a sustainable energy path. We called it the A1T 450 scenario because it based on A1, which is strong economic growth. The letter A stands for strong global economic growth. 1 stands for we obey international law and we follow, if we have, conventions of the United Nations. T stands for we love technology. If we have the fuel cell ready, it will be on our roads. And 450 stands for the maximum allowed equivalent carbon dioxide concentration, standing for 450 parts per million by volume. And we hoped that under these conditions, we would keep the system below 2 degrees Celsius mean global warming. We gave 500 kilowatt hours to any person on this globe per year in order to guarantee a development, because development needs modern forms of energy. Without electric current, you are lost. So you need a plug. Compliance with UN conventions. I wrote it again here because there is one convention of the United Nations which nearly no citizen knows, which has a strong impact on the way we are dealing with our system. It is the Convention on Biodiversity. It says, and this is international law we have to follow, it says each country has to protect 10% at least, better 20% of its surface, including river systems, from use in order to allow biodiversity to migrate. And this reduces the possibility for hydropower, for example, strongly, because you need to have river systems, at least 10, better 20%, still in a natural setting. And this is international law since 1994. It was signed in Rio, this convention, and it became enacted in 1994. Further assumptions. We always take the cheapest energy supply calculated over the full lifespan of an installation. This is not done up to now. We would have a different power plant composition if this calculation would have been done over 40 years or 50 years of an age of a power plant. Standard wisdom is we calculate over the next 10 years because we don't anyway not know what the political decisions will be. Let us start. If it is cheapest for the next 10 years, we take it. That's why in recent years, to the advantage of the climate system, many gas-fired combined cycle plants emerged because they were the cheapest. You had no opposition by the people. Investment was comparably low. Efficiency is higher than for a coal-fired power plant. It's now between 50 and 54%. And you can run it after 2.5 years after the start. That's why many of these gas-fired power plants emerged in recent years in many countries. And coal-fired were kind of lagging because more expensive, population started to be against it, like in our country here, very close to this place here, there is the hugest assembly of lignite-fired power plants in the world. And each person in North Rhine-Westphalia emits very close to what an American citizen emits. Above 16 tons of carbon dioxide per year for a citizen of North Rhine-Westphalia. Why is it so? Because this state delivers the electric current to the other. The lowest emission is in Thuringia. They have no big power plant at all. So they just import electric current from the other states of Germany. The Bavarians have a comparably low emission because they have a lot of nuclear power plants, and they have what I call Kulisse, the Alps. And so they have about 15 to 20% of their electric current from hydropower. About 85% of the electric current produced in Bavaria is close to be without CO2. Further assumptions, energy productivity growth shifts from 1% to 1.6% per year. 1.6% per year energy productivity growth is the maximum which was shown up to now by some of the very highly developed countries. So the most innovative countries reached it sometimes. And we said policy making would lead to 1.6% if it is a real policy, like for the European Union, where we have now not a binding goal, but a goal which says 20% increase of energy efficiency in 2020 compared to the date 9th of March 2007 when the decision was made. I will show what this means. This means roughly a third of all the energy you would need with the old system is no longer needed. This efficiency increase is a very important point in getting the proper scenarios. Sequestration only in former gas and oil reserves or reservoirs with maximum storage capacity of 300 gigatons of carbon. In the meantime, more is discussed. Let me talk about for which purpose is carbon capture and storage meant. The most modern way of debating it is taking methane hydrates out of the ocean bottom, use it as natural gas, and store carbon dioxide as carbon hydrates, carbon dioxide hydrates at the ocean floor, because carbon dioxide hydrate is as stable as the methane hydrate. And the colleagues in Kiel do research on this. Can we bring carbon dioxide into these cages? So the hydrates at the ocean floor. The next point for carbon capture and storage is bring it into saline aquifers. It was tried by the Norwegians. It was successful, but it was given up because the CO2 tax was too low to make it viable, attractive, economically attractive. It's the famous exercise, 25 million tons of carbon dioxide were brought below a sandstone layer in the Norwegian part of the North Sea. And now drillings are made to find how does the carbon dioxide wander around. First, they thought it would go up immediately to this sandstone layer which keeps it. In reality, it just went horizontally, because if you dump carbon dioxide below 800 meters below surface, then it is a supercritical fluid. And it likes to be in a porous rock and stays there. Why did natural gas and carbon dioxide, always accompanying each other, in many cases accompanying each other, stay for many millions of years in these layers? Because they are really fixed to it. It could be carbon dioxide, it can be sulfur dioxide, it can be methane, and some other gases. You can store them in these layers. So that's why I personally am not afraid of keeping this for a long time below the surface. But there are many more problems related to it. You will never have agreement in international law to dump it in the open ocean, where a neighboring country is afraid of getting the problems later. So if carbon capture and storage is working at all, it will work in a nation, on their territory, if the population agrees. And population must not agree, even if there is no scientific finding that it would be dangerous. So voters are sometimes very strange, as we all are sometimes very strange in our behavior. If you would use gas and oil reservoirs, then you could only store 300 gigatons of carbon. But when you realize that we now have reached emissions of about 10 gigatons of carbon per year, 300 gigatons of carbon is not a big storage capacity. So it would just be available for some decades. And then all the deposits we had earlier for oil and gas would be filled. It's not an easy job to find the proper deposits. Now to this energy scenario, which includes the allowance for carbon capture and storage. The upper green part is the shift from 1.0 to 1.6% per year energy efficiency increase. So you can save more than a third of all what you would need in 2100 by just going into this moderate efficiency increase arena. The yellow is the full use of direct solar radiation. It must take the lead later. A simple calculation of a physicist now. Let us talk about the technical potential of renewable energies. First comes the sun, with 169 watts per square meter on global scale in the mean. In Germany, 115 watts per square meter, as measured by the German Met Service. Number 2 is wind, but the entire dissipation of kinetic energy in this system is maximum 3 watts per square meter. So a small portion of it could be used. Next comes geothermal energy flux from the Earth's interior. Now we are down to values well below 1 watt per square meter. It is 0.1 watt per square meter on global mean. It is 0.08 for Germany. It is due to radioactive decay and the solidification of the most interior of the Earth. Both sources create this energy flux upwards. Next is biomass, also roughly 0.1 watts per square meter. Very low energy density. And now a question to you, how much does Germany use? Energy flux density averaged over the Federal Republic of Germany. I would like to hear your numbers. Five, 4, 3, 2, 1. It's 1.5 roughly. Or in other words, a well-fertilized maize field in Germany has 0.3 watts per square meter biomass production rate. How much would you need to get the 1.5? So you need several other Germanys, 5 times the area of Germany. Would you allow now 20% of the German territory to be used for bioenergy purposes? Then we are talking about a few percent of our energy input from biomass. This back-of-an-envelope calculations of physicists are typically the starting point of any debate. So why aren't you using then the 150 watts per square meter from the sun on top of each roof oriented southward in Germany? Then you have an energy flux density which is much higher. So these are the questions I have at the beginning of a debate. What can renewable energies deliver? I'm not talking about Brazil. I'm not talking about Siberia, where maybe this is viable, but not for a densely populated area like Germany with a high throughput, 1.5 watts per square meter, which is less than the dissipation of kinetic energy in our country. So the warming of our country in the planetary boundary layer by reduction of wind speed is higher than the warming by waste heat in Germany. Or in other words, waste heat is no problem at all concerning climate change. It's much less than the factor of 100 to 200 you have to multiply when you deal with CO2. Because we are talking at present already about 2.5 watts per square meter increase in the energy budget of the Earth due to the growing concentrations of greenhouse gases, while the global mean energy input by humankind into the system is 0.03 watts per square meter. So we should not debate waste heat. We have to debate emissions of greenhouse gases and emissions of precursors for aerosols, because we Europeans have accelerated global warming strongly by our environmental laws, because we took out the particles from the big chimneys and also the precursor gases like NOx have been attacked, and SO2. Burden sharing, contraction and convergence. This is the diagram our chancellor now favors. And there was a reply by Indian colleagues who said, we are gracious to you if we accept contraction and convergence. In reality, the proper calculation would be you are responsible for the buildup of the concentrations as well. So it would be, we would need a stronger scheme than contraction and convergence. Our chancellor calls it Emissionsgerechtigkeit. She spoke about it in Kyoto in autumn 2007 and said, in the long run, the only justified way of dealing with climate change is the right for emission by each individual, which is contraction and convergence. Look now at the figures. The West European Union, which is very close to what we now call the European Union with the 15 old countries, they are in a comparably good position because we are much more efficient in using energy than the United States of America. The Soviet Union, the former Soviet Union, FSU, jumps up again if they take up economic speed, which is now real. The same is true for the former East Bloc countries, this envelope around the Soviet Union. The only area where a strong growth would still be allowed is Southern Asia, India, SAS abbreviated here, and Africa. These would be the areas where emissions would be allowed to grow in such a scenario. It's now a detailed picture, and look at hydroelectricity. You nearly need a loop to find it. Why? Most countries are flat. Germany has at present, using all we can get from our rivers and damming creeks in the Alps, 4.2% of the electric current, which is 0.022 watts per square meter. So nearly nothing. And only very few countries still have a possibility to increase hydroelectricity. Wind will play a major role. Modern biomass, advanced called here, also in some of the developing nations having a large territory. But solar power, be it from photovoltaics and solar thermal generation, will have the main burden for the future energy supply system. And geothermal will be small because you cannot go beyond these 0.1 watts per square meter. Otherwise, you cool the area below you. And physics is following natural laws. This was not liked by the geothermal freaks in Germany. I got a letter because I was chairman of this committee in 2003, and we needed to discuss with them. We did. And the final outcome was our estimate was higher than their estimate. But we allowed the development of the developing nations, which was not on their bill. You cannot go along with industrialized countries alone and keep the poor poor. This is not accepted at all. And finally, through globalization, we got this push of the development in the developing nations. with some of the drawbacks, as we all know. Coal will no longer be available in 2100 for the energy supply system, not because it would not exist, but emissions trading schemes would eradicate coal. Because if the correct price is applied, then coal has no future. You should not talk about this with RWE, building the most polluting power plants in the world concerning CO2 emissions. 1.8 gigawatts in one single power plant, very close to here, Neurath. I looked at it. It is under construction. It will work. It will be a lignite-fired coal power plant or a lignite-fired power plant, and it would be the single largest CO2 source in the world. And this is done in a country which states we would like to be the leaders in climate protection. Nuclear power is fading away. It has at present 2.3% contribution to the energy, primary energy of humankind, and it shrinks since about 15 years in its contribution because nearly no new power plants are built and some old are already decommissioned. So the contribution to the energy supply system by nuclear power is shrinking. And the number of power plants also, since about 2000, the number has shrunk. Now to carbon capture and storage. Now we go to A1T, B1, and B2, 3 scenarios. The upper line is what would happen in emissions here in gigatons of carbon per year when we would follow A1T, B1, and B2. The lowermost curve is getting the 2-degree goal correct. And the lines in between show you what you can do by demand reductions, which is efficiency increase. It's the upper green parts, or yellow, it looks yellow here, of the diagrams. And the centerpiece is structural change, which means we build solar thermal power plants in southern Spain and transport electric current to France, and the French transport something to us, and we give the wind energy to the Bavarians because they have no wind, but the North Germans have enough. And since the big companies now stepped into wind energy, we will get the net. We have no problem in the near future with the net because the big ones like it to have wind energy from the North Sea, because they got in the recent change in our renewable energy law plus 3 euro cents per kilowatt hour if they go offshore. Onshore, the prices remained as they were. Offshore, they were increased by 3 euro cents per kilowatt hour. And the dark lower part is carbon capture and storage. If you want the 2-degree goal and such a scenario like A1T with 450 ppm, you need, if all the guardrails I showed you are kept, intermediate carbon capture and storage, unless you go for B1, which is the transformation of an industrialized society into a knowledge society, but with no serious climate protection. Then you could work down to 400 parts per million by volume, but then sequestration or carbon capture and storage must be applied to biomass use. The only way to reduce the carbon dioxide concentration in the atmosphere actively is biomass use and carbon capture and storage. I'm advisor to the Bavarian government, and I said, why aren't you the first state in our country trying to do this, and at the same time at a place where you can use geothermal heat? Then you would be innovative. They did not accept it until now. But as always, this is my experience as an advisor to governments. It trickles down. If you make a proposal in the first year, it normally is just debated in the cabinet and then given to the parliament, and somewhere it is fading away. But after some years, when the debate continues, they take on board again what was written or given to them. I'm now very close to the end. Conclusions. Stringent climate protection scenarios need CCS at least intermittently if we adopt strong economic growth as our main principle. This was the prerequisite in these scenarios. If we would try to learn how to keep a system running without major economic growth, which would need a redistribution in countries, which is much more difficult than growing and giving every group a small surplus. This is the easiest way of development. Give the rich something, give the middle class something, and give the poor something. But then you need economic growth of more than 1%. You need 2, 3, 4, and even 5%. That's why we adopted A1T as our preferred model, giving advice to the German government. CCS shrinks strongly with early internalization of externalities. So a stringent emissions trading scheme of the European Union, now also debated with Barack Obama to have a transatlantic emissions trading scheme, would be a major big step in avoiding carbon capture and storage. I am convinced that engineers will find a way to store carbon. If you give them this task, in about 10 years, they have a possibility. Whether it can be implemented is depending on the society, on us voters. But feasible, the feasibility, they will, with high probability, show. We need the demonstration of technical feasibility for CCS very soon. At present, we have only pilot projects. We have a small power plant by Vattenfall in the area of Lausitz at the border between Brandenburg and Saxony. And we have a few attempts in the United States of America, but the real feasibility is not yet shown. Now I stop because I got the signal by the boss of this workshop here. Clemens Zimmer said, by pointing 3 times to the clock, please come to an end. Thank you.